Here continuing the videos on what is parametric modeling and why use it. In the first two, we dealt with creating a saxophone end plug, which has a tenon and a top, and how we use the VarSet function to be able to change those two parameters to fit different saxophones. In part two, I described how to do this using the parametric modeling function available in Spreadsheet. Well, we're going to go back now to the VarSet function, and we're going to go ahead and add ribs around the top of the saxophone plug. There's a couple of main points here, and that has to do with the sketch of the top ribs must be tied to the base of the top. And I'll say more about this in a second. This is necessary to allow the padded sketch of the ribs to move correctly when the top height is changed, or when the tenon height is changed. If the bottom of the rib is tied to the plane of the bottom of the top, when the length of the tenon decreases and the top moves down in the Z direction, this way the ribs will stay aligned. The other point we're going to talk about is the center point of whatever geometry we use to create the top rib sketch must be tied to the diameter of the top diameter to allow the ribs to move synchronously when it's changed. And I'll say more about this in a second. Sorry. And the last thing we're going to use is the polar transformation tool to take those top ribs and move them around and make copies around the outside of the top. Sorry, folks, for my cough. It's important to comment that when you're in the part design workbench and you use the polar or the multiform transform tool, whatever you are transforming must be tied to an existing geometry to anchor it. If it's not, you will get an error message saying that the array is not tied to a support. Okay, so once again, here is the thing we're building. And as I commented, we will go ahead and tie these ribs to the bottom face of the pad of the top. That will allow them to stay in alignment when the tenon moves up and down. Okay? So let's get going. All right, so here's where we left off. And as we talked about now, oh, my phone is going off. Everybody's texting. Let me turn off the sound. There we go. Okay. So as we talked about this, the ribs that we're going to create have to be tied to the bottom face of the pad of the top. So let's select the bottom face. Oh, we should make the tenon go away. Let's hide it for now by hitting, the little eyeball here. Let's select the bottom face of the top and create a new sketch. That sketch then is anchored to the bottom of the top. Oh, it wants me to, if we didn't create the active body. So let's go ahead and make sure the active body is there. So, okay, so now we can create the sketch, which is tied to the bottom of the top. The bottom of the top. To do this, we're going to go ahead and create a centered rectangle. We could use other geometries, but I decided to do it this way to show some other things. So let's go ahead and draw ourselves a centered rectangle. And you'll notice that I have the centered rectangle starting on the x-coordinate axis. Okay? Now, of course, any rectangle, to be fully constrained, we must constrain it in with respect to its length, its width, and its distance from the origin. So let's go ahead and click our constraint tool and give ourselves some constraints. So let's just call it 7 just for the heck of it. Let's call this, let me click again. Let's call this 4 millimeters. And let's call this, just for now, the distance to the center point of the two axes. Let's call this 13.5. Okay, so now we have a fully constrained sketch. And if we close, we can see the sketch is there. Let's go ahead and pad the sketch to make the rib. So once again, we've got the top as the active body, has to be, right? Because we couldn't have created the sketch otherwise. Let's click on the sketch and let's go ahead and pad it. So you'll notice that what happened is that the pad moved in the opposite direction that we wanted. And that has to do with how when we selected the bottom of the top, positive Z goes down. No big deal. Let's just reverse it. Okay? So we've reversed it and now we're okay. Well, let's go ahead and round these corners. Okay? Let's do this in the sketch. So let's go to the sketch of the ribs, just to show you a different way to do this. We could have, of course, rounded them off in the pad itself, but let's do it in the sketch so we can show how to use the fillet, the fillet tool in the sketcher. So I select the fillet tool, select the two sides I want to fillet. There you go. Select the two sides I want to fillet. There you go. Now you'll notice that we're now we're now under constrained. And that's because we now have to constrain these two fillets. So let's right click to get out of the tool. Select the two fillets. Give them an equality constraint. And now let's constrain the angle of the fillet. Constraint tool. Let's just make it 1.5. All of this, of course, can be changed. Okay? Now, as I've described, let's go back, we'll close, and we can see now how the rib looks. Well, I don't particularly like the way this looks. It's just too far out. So let's move this rib in. And in doing so, we have to now use our VarSet functioning to tie where this rib is in relationship to the top. Because if we simply changed the radius of the top by changing the top diameter, which, by the way, from the first video is tied to the tenon diameter, but let's go ahead and just change this to 27 and look what happens. You see the rib does not move with it because we have not tied the center of that geometry to the diameter of the top. So Control Z to go back. Let's go back to our sketch. And now let's go ahead and select this distance to the center of the top and anchor this distance to the radius or the diameter of the top. So we now have, we've opened it up. Let's go into the expression editor. Type in VarSet, right? Because that's what we're using, VarSets. And we're going to tie it to the top diameter. Okay? Let's click OK. What happened? Oh, we don't tie it to the diameter, do we? We need to tie it to the radius. So back to the expression editor, top diameter, divided by 2. There we go. But it still looks to me like it's a little far out. So let's move it in a bit. So let's go back to the constraint. Go back to the expression editor. And let's take away 1 millimeter. Let's see if that looks any better. Just minus 1 millimeter. We moved it in a little bit. Let's move it in a little bit more. Let's make it 2 millimeters. And by the way, there may come a time and a place where you have to put these in parentheses. I didn't have to here. Yeah, that looks good. So there we have our rib. Okay, and the rib now, so if we change the diameter of the top, the rib should remain synchronous with it. So let's go ahead and change the tenon diameter, because like we said, the top diameter is tied to that. Let's make it 27. Yes, and you see, in fact, it's tied. Let's go back to where we were. Now, in my original model, let's bring back the tenon by clicking on the eyeball. In my original discussion, this is not flush with the top. I have it 1 millimeter below. So let's go ahead and use VarSet to always keep the height of the rib 1 millimeter below the top of the top. Okay, let's go into our pad, because obviously the height of the rib is related to the pad size. Expression editor, VarSet, tenon top height minus 1 millimeter. Okay, just bringing it down just a little bit. Okay, okay. And so now if we change the top height, there should remain to be 1 millimeter. So click on VarSet, top height, make it 14. See? Looks good. Control Z to bring it back. All right. So now we're ready to take the rib and create a polar array around the top. Now I want to take a second, I should probably do a separate video on this. Within part design, whatever we choose as an object or a sketch, a padded sketch, to create an array, it must be anchored. If it's not anchored, then it will fail. Maybe I'll make a point about that. Probably I should label these things. So that pad is actually, let's rename that to be top height. Okay, let's rename this pad to be rib height, just so we can keep ourselves straight. Okay, we can change the name of the sketch to be top sketch. This sketch can be then rib sketch. This might help me later kind of keep everything straight. Okay, so we have to make sure that the top is the active body, and it is. Let's go ahead and select the rib and go to up here to the polar pattern. Now the polar pattern screen shows up, and the first thing is the axis is going to be defined by you or me. Normal sketch axis, which works here just because of how we've done it, but we could make it the base Z axis, right? Because we're rotating the ribs around the Z axis. Let's go ahead and make them 6 of them and click OK. Well, there we go. That's how to use the polar pattern. Well, let's go back and get rid of the polar pattern, and I'll show you how to use the multi-transform tool. So I'll delete that. Rib height. The multi-transform tool is over here. It looks a little different. Let's click on that. And the first thing you'll see is the body that's going to be transformed is rib height. That's correct. You can add or remove features, but it's correct because we had it selected. We have to right-click to add transformations, polar patterns. Now we're going to get the same here, right? We have to define a sketch axis, which is normal, is fine, but we're going to define it now as the base z-axis, and we're going to give ourselves 6 occurrences. And there we go. And now these are all tied together. So if we change the height of the rib, well, no, let's go ahead and go back to VarSet. So now if we change the height of the tenon, everything will move correspondingly. So let's drop this to 15. See, it did. Everything looks still good. Let's change the tenon diameter to 18. And see, everything's fine. The ribs, the top, everything moves correspondingly. Okay? Well, I think that's about all I want to do for this video. I'm going to do a separate video, very quick video, on how the polar pattern can fail if the sketch does not intersect. But for the purposes of, I think, what we're doing here, I think we're pretty much done. Okay, bye guys.